Okay, so we're going to continue on with our Unit 3, Topic 4 notes. And we are on page 22. Get your notes out to turn to page 22. We will do 5 examples with row reduction. And then you have 4, I believe, to do on your homework. I will post those videos as over the break. Okay, so we already know what row reduction does in the calculator. It takes it to ones and zeros, and then the answers are on the right, but now we're going to do them by hand. All right, so it says, when we solve a system with a matrix, the calculator is performing a series of row operations. In row reduction, the following row operations are allowed. So we can switch 2 rows, and we label that with R1 switches with R2 if we're switching rows 1 and 2. We can also multiply by a scalar, so just one row. We don't have to multiply the whole matrix. We can just multiply individual rows, and we label that with the row that we're multiplying. So let's say we're multiplying row 3 by 2. Another common one is, instead of dividing a constant, we multiply by the reciprocal to get the scalar. So we would do 1/2 times row 3 if we're trying to divide everything in row 3 by 2. All right, and then the last operation we can do is we can add 2 rows together. We can replace a row by the sum of itself and the constant multiple of another row. So that means if I have 2 rows together, so let's say I add row 2 and row 3, and I want to multiply row 3 by 2, you write it like this. The first row tells us which row is being replaced. So in this case, I would be replacing row 2 with the sum of these 2 rows together. Okay, so we'll work through some examples. So we already know this part. Gaussian elimination takes us almost to ones and zeros. So right here, the thing that we write is an augmented matrix. So this is what you end up plugging in the calculator. And with row reduction, we change the augmented matrix to reduced row echelon form. And when the calculator gives your answer, you see the 1s, 0, 0, 0, 1, 0, 0, 0, 1. This part is called the identity. The identity matrix, and then you have your answers over here, whatever your XYZ answers are. So we will get to ones and zeros by hand. Now you don't have to get it all the way by hand. For extra credit you can, but we just normally get the bottom triangle into zeros, which is Gaussian elimination. The full one is the row reduced echelon form. All right, so to get our answer, we know we always look at the last column and we get our XYZs. So again, what is this row reduced echelon form telling us? It's telling us that 1x plus no y's plus no z's is the first number, and then so on. 1y is equal to the second number, and then 1z is equal to the last number. All right, so we're gonna do these by hand. So right here, we know how to do the augmented matrix. So we know the coefficient of x here is 1, so it's 1, 2, 3. And then the second one is -1, 1, 0. So for this one, our goal, I'm gonna write the goal over here, is to get this to look like 1, 0, and then we could get 0, 1 here. We don't have to go that far. But as long as we have ones and zeros here, these other ones can be numbers. So this is reduced echelon form. If we go all the way to 1, 0, 0, 1 numbers, then this is row reduced. I won't make you do that far all the way, but this one you have to do. All right, so we're gonna take this and I'm just gonna copy it over here. 1, 2, 3, -1, 1 and 0. Now on the arrow to get to the next one, we write what we're gonna do. So remember, we're trying to get this thing to be a 0, this number right here to be a 0. So we add these two together. So if I add, row 2 is being replaced, so that's the first R, and we're gonna add it to row 1. So row 1 is not gonna change. So I'm gonna leave row 1 as 2, 1, 2, 3. All right, and then I gotta figure out what number do I have to multiply one of these by, so then when I add these together, I get 0. Well, if we notice, if we already add them together, 1 plus -1 is the 0 that I need. So we actually don't have to multiply anything here. All we do is just add the rows. So we're gonna add 1 plus -1 is 0, 2 plus 1 is 3, and 3 plus 0 is 3. All right, we could actually take this one step further and get a 1 here. I mean, we could stop there, but just to practice some more row reduction, let's say we want to make this a 1. Then we would have to divide this row by 3. So we're not going to do anything to row 1, that stays. So row 2, and instead of saying divide it by 3, you just say multiply by the reciprocal, which is 1/3. It's the same thing as dividing by 3. So we're going to divide everything by 3 here. And when we divide by 3, 0 divided by 3 is still 0. 3 divided by 3 is 1. And 3 divided by 3 is 1 here. So this is telling us one of the answers. Remember, this is x, y, and what it's equal to, the constant. So this is telling us that 1y is equal to 1. So right now I have one of the numbers, 1. Now I need to find x. So what we do is we take the first row here and we say this row means 1x plus 2y's is 3. Well, I know y is 1, so this is x plus 2 times 1 equals 3. So x plus 2 equals 3 minus 2, x is 1. So I know here x is 1. So this is called, so if you read it right here, using Gaussian elimination, that's this part, to reduced echelon form, and then we use backward substitution to go back and get the x to get the x to begin with. So that's what we're gonna do. That's what you have to be able to do, is to get it to reduced echelon form, and then you're welcome to plug it back in. You don't have to get it to 1s and 0s. I will do a few examples that get it to the identity matrix, but as long as you can get it here and then use backwards row reduction, then you can get your answer that way.